Um, so what we have here is a lab that we are connected to remotely. If for some reason bandwidth will be slow enough, I'll just switch to a recorded demo. Thank you. What you see in this lab is a lab that demonstrates many of our basic architecture capabilities, as well as some of our cloud features and unique capabilities. So I would start with, first of all, high-level overview. What you get to see here is basically 3 sites. We have this site, which is an end customer side of a cloud. We have the cloud side, which is, and it's coming. Okay, we have the cloud side, which have multiple sites paired with it. The equivalent in the enterprise case will be, let's say, my primary data center with different branches connected to it, right? And here we can see, again, high-level view. We can see things like the connection topology. Okay. So we can see the connection topology, right? Where we can see the multiple sites that are being connected. I have a third site here. It won't be very different from the first site that I showed you, so I'll skip it for now. First of all, you can see that most of everything that we do is integrated into vCenter, and it's integrated into vCenter in high level of integration. It's not just single pane of glass from the GUI perspective that basically get to manage everything from the same console. It's deeper integration in terms of roles and permissions, auditing, alerts and alarms that are being funneled through vCenter. We really went the extra mile in terms of making sure that our integration with the virtual infrastructure is whole and complete. Other things that basically can be seen here, again, when we're talking about the cloud side, which could be similar to the master side if you wanted to relate to that. We can see the list of applications that are being protected here into this site. We can see the list of virtual machines that are being protected into this site. We can see the different sites that are paired with us, right? In a simple enterprise deployment, that would basically be our sites that are replicating, that are associated with this site and replicating into it. In a cloud scenario, there will be other capabilities that we can basically add to the site management in order to basically provide tenant management capabilities. So I'll talk about it in more details when we get to talk about the cloud architecture, but there are things here like resource abstraction, resource assignment to different tenants, what is exposed to them as replication targets in the cloud, and those could be vCenter level or VCD level with deep integration with VCD. So close this window. The next thing that I want to show you is, what it basically means to protect an application. So we have a VM here. And I'll change location in the tree in order to make sure that it's
I see, yeah, it's not in this slide or in the other. 5.0, vCenter 5.0.
mm-hmm.
Is 5.1 also?
Supported already,
okay.
Yeah. 5.1 is supported.
Does it matter which version of vCenter you have at either end, or even ESX host? You know,
Whatever
you know,
version.
4 at one end, 5 at the other.
You can go any version to any version. We support anything from 4.1 currently to 5.1 in any direction. The only thing to mention here is obviously that if you're using any advanced features of the hypervisor, we won't be able to downgrade them if you try to recover to a lower version, right? If you're using hardware version 9, we won't be able to make it run on 4.1, right? There's that we cannot do. But as long as you stay on the common denominator, then we can go in any direction. So again, from the customer side, I'm going to basically want to protect this CRM VM. I'm going to click on protect as standalone VM, and I get the protection screen. What I have here is basically a site that is configured to protect and recover within the cloud's vCloud Director resources. So in the backend, there was basically an org defined and an org VDC associated with this customer. And this customer will basically replicate into the org VDC that was assigned to him, and that's where they will also recover. From a replication policy perspective, we have several parameters that allows you to basically control the SLA. So, and here we come back to the question that that was asked on priority. There are a few policy parameters. The first policy parameter is priority. Different applications will have different priorities, right? We stream the data constantly, but obviously if there is peak over, peak in the change rate, or for some reason we cannot accommodate all the changes over the wire, we need to decide which application will get better priority. So to make it simple, we left it at 3 different levels: high priority, medium priority, low priority. And basically the highest the priority is, that's the priority that you will get on the wire. As long as there's enough bandwidth, things will be streamed anyway. And Zerto will strive to keep the RPO as low as possible all the time. But again, if we cannot accommodate, that's where the priority will kick in. And it keeps it very, very simple to manage. Does that answer your question?
Partially.
Okay, so.
How much WAN bandwidth control do I have? Because I've got a link between site A and site B, but that link isn't dedicated to
Excellent
DR.
question.
I've got users in site A accessing applications in site B.
Excellent question. And you know why it's an excellent question, right?
Because you have an answer.
Because I have an excellent answer. So, at the site level, we can basically go into the advanced mode.
Well, of course, it's always in the advanced mode.
Right. And we can basically throttle the bandwidth. Okay?
But I can't build a schedule.
Right? Sorry?
I can't build a schedule.
Currently not.
Because nobody works in site B from 6 p.m. to 7 a.m. And you might as well use
that. It's actually 7 p.m. now.
Thanks,
Right.
Scott. I needed that.
Right, so
But-
we cannot schedule it today, but the capability is here, and trust me, building a scheduler on top of it is not as complex as it may sound, right? It's not that complicated at all. So yes, we
Okay,
have.
so I say that, of this, wow, 77 meg, you guys can afford bandwidth. But I say of this T1 line, only use 1 megabit per second for replication.
Yeah.
And I've got applications that I've declared to be high, and applications that I've declared to be medium, and applications that I've declared to be low,
Within
and they
this
add up to
routine.
more than that.
And they
Their
may
their
end up to more.
replication demand adds up to more than that. What happens?
So, again, excellent question. When you don't have enough bandwidth to, so this VM is generating I/O, right? And this I/O is bigger than what your pipe can accommodate, regardless of whether you use throttling or not, right? what we would do is we would go into a bitmap tracking mode with the system. The system will automatically switch to this mode. And it starts to track the delta changes, basically the blocks that got deltified during this peak period where we cannot accommodate the changes over the wire.
Okay,
Right?
so you're journaling.
We journal it, but not on the disk. Okay, that's a key point, because we don't generate IOs locally at any point in time, right? Generating IOs locally on the production side will have effect on production, and that's something that we don't want to have.
Okay, but if the WAN link goes down,
Mm-hmm.
and some of my clients have locations, places where WAN links go down, like Hoboken.
They will go down at some point, by
Yeah.
the way. That's networks, right?
Right. So you're not going to journal to the disk.
We're not going to journal to the disk.
So then when that WAN link comes back up, you're going to have to resync the whole disk?
No, that's what I said. We are tracking the blocks that changed during the one outage, and we will sync the blocks that changed, because we keep a bitmap, a very efficient bitmap, by the way. I don't want to derail too much from the demo, because then we can kind of lose the main points. But and I'll be happy to extend about it if you want later on. But there's a very, very smart bitmap here and few very advanced mechanisms that allows us to sustain a prolonged outage and synchronize only the delta changes, only the blocks that changed during the outage when the one link comes back again.
Okay, so you're not data journaling to disk. You're
No,
block address journaling to memory.
right. You could, yeah. That's a good way to put it.
Okay.
Right. So we will keep them here, and
All right. So but now let's go back. WAN links up.
Mm-hmm.
I've got several VMs that I'm replicating. Some of them are high priority, some of them are medium priority, some of them are low priority. The total amount of replication bandwidth that I require is more than the available bandwidth.
Of course.
What happens?
So we start to stream the data based on priority, and we don't starve any application, but we will give them priority, different priority basically, and they will catch up. Now, we cannot change the rules of physics, right?
But you could say, well, there's only enough bandwidth for the high priority, and the mediums and the lows are going to have to wait till traffic levels reduce, and I'm going to use the journal to keep track of that.
Right.
Or you could say there's not enough bandwidth for everybody, and so of the 10 available ticks on the clock, high gets 5, and medium gets 2, and low gets 1.
Which is similar to the second.
Clearly, somebody gets starved. The question is, how badly does it get starved, and is that under my control?
Right. So when I say no one gets starved, I meant no one is, getting zero. It's not about getting zero. We will try to push the data between them. The highest priority will get highest priority over the one. They will get more ticks of the clock, if you want to call it that way. But no one will get zero, and basically they will progress the lower priority with lower pace. Okay? We could do it differently. We did it.
Right.
It's not extremely difficult to implement it differently. Actually, implementing this algorithm is a little bit more difficult than
Completely starving is easier.
starving completely. So
Okay, but now my low priority task. See, what I don't see is how you maintain, with the kind of block journaling that you're doing, how you maintain right order integrity. In that,
it's a good point. I'll explain it. So
I can see how you can come back and resync, but I can't
Right.
see how in the middle you're.
I understand what you're asking. It's a good point. So everything that when we stream, and it will be, I think again, better understood when we'll get to how recovery looks like. But when we stream all the time, the system automatically generates consistent point in time for recovery. Consistently, all the time. Every few seconds you have a consistent
Checkpoint.
point in time to recover from, right? A checkpoint. Basically, if there was one outage and we need to sync a specific change, right, that was during the one outage, this whole recovery will have to finish before we can create the next valid checkpoint.
Okay,
Okay?
but
That's
if-
the
if-
next consistent image that we can create.
right, but if,
because
but
we
if
will
we're
not
not,
have
if we're
the
not
right
talking,
order
if we're not
fidelity.
talking about a WAN outage, but we're talking about a bandwidth shortage situation.
It's the same thing. It's the same thing.
Okay, so recovery. So
If I
I'm
go
not going to
into-
have. So I'm not going to have any consistent. I'm not going to have any recovery points if my bandwidth shortage runs long term. If I just didn't give you enough bandwidth, it's never going to be consistent.
No, that's not true. We have recovery points here. So we have a journal, right, on this side, and you had consistent point at some point. You synced. The data synced, right? We at the pace that we could, we streamed the data, and we have consistent point in time to recover from, right? You had one outage. Obviously, we cannot stream the data when
Right, but
when there's
I don't have a WAN outage. I have
shortage of
I have a shortage of bandwidth,
shortage of
and I've got an
shortage-
application that's writing to block 74
Right,
every millisecond.
correct.
And you only have enough bandwidth to send 900 of those 1,000 changes to
Right.
block 74.
So
over the-
your RPO, right, in this case, and I assume that we have to correlate the RPOs that you want, the bandwidth that you're willing to invest in, right? Your RPO targets will have to be set appropriately, right? It means that when you have a peak, these writes will be bitmapped and synced
But you,
as soon
but
as
you,
possible
but you told me
within
that
your RPO targets.
yeah, but you told me that you weren't journaling the data, that you were just journaling the change block addresses. So if I have an application that is continuously updating a database index, which is a very small number of blocks with a very large number of updates,
Yeah.
and all you know is the block number that got updated, then the only data that's available to you is the last value of that block update, not
And
all of
that's-
the intermediates.
And that's why the next consistent point that you will have is the next consistent point where we were able to synchronize all the changes consistently and create a valid, consistent checkpoint, right? That's exactly the reason. You won't have consistent points in between. We couldn't stream the data. We'll take the whole bunch, sync it, send it over. Once we were able to send the whole bitmap, synchronize it, and define the next point in time. There's a little bit more technical details here, but I'll put it aside for a second. I mean, we have to keep it at some level, for everyone to understand. So there's a great deal of detail here, but just to try and keep it simpler, you have this bitmap. It changed. You have to send the whole bitmap over, persist it in the journal, then you have the next valid point in time to recover from. Right, so this block changed 5 times. That's fine. You have the last change, correct. But the last change is at the point of time that we are creating, that's the consistent image of the disk.
We can't resolve this without getting a lot deeper.
Yeah, so I'll be happy to do it.
Unfortunately,
I'm willing
we don't
to
really
let
have
that-
time to
yeah,
look
no,
at
Yeah,
it.
let's,
I'm willing to
I'll be
let
happy
that
to
go.
do it. I'll be happy to do it. And by the way, if
Yeah.
we don't have enough time, I would be more than happy to schedule one-on-one and go over it in
Yeah,
the greater detail that you want.
Let's let
me
it
for
go,
the
'cause
greater
there's no
good
way. Yeah.
move forward. So, okay? Okay. Excellent. So, we were in the middle of creating a new VPG. So we talked about priority and explained bitmaps and tracking, right, and some of the efficiency, RPO objectives. So the one thing I want you to take from the RPO objectives is that we're not talking about schedulers. There's no snapshot shipping. There's no quiescing of the application in order to create the checkpoint. These checkpoints are created automatically, continuously, all the time. Right? What we have here is basically the policy that you want to have. So what's the SLA that I want to have for this application? I want to have RPO of 2 minutes, 10 seconds, 15 minutes. By the way, we are going to increase these values a little bit to allow different applications that don't necessarily need to be so aggressive. We're going to allow them to basically have their SLA defined appropriately. The next thing is the CDP journal history. And the CDP journal history is set in terms of time. So, let me go back to the board. We have the journal file here, right? This journal file is, in essence, a VMDK, a Zerto VMDK, that we're using in order to journal the changes so that we can recover to any point in time in the past that is within the journal. Now, one of the key things that we're trying to keep is we're trying to keep things extremely simple. If you think about it in terms of, and you're all storage people, if you think about the equivalent goal in the storage world, you usually need to have a disk or a LAN or an area where you can actually pick the journals, right? And you have to make sure that according to how long you want to be able to go back in time, you have to make sure that you can actually have enough space, right, to accommodate the points in time that you want to have, right, the amount of history that you want to use. We allow you to set it in terms of time. We can leverage the dynamic nature of the virtual environment and how easy it is to use the virtual environment and provision disks and provision space and make changes on the fly in order to do the job on our own and take all the burden of managing it. Right, now obviously, the immediate next question is, okay, but if these 4 hours are gonna be 5 terabytes of data, I don't want it to eat my whole space, right? So the next thing that you can do is you can basically cap it. You can say, I want 4 hours, or 12 hours, or 5 days, but I don't want it to grow above a certain size. Right? That's what I'm willing to give it. And if it will hit this size limit, we will obviously won't go beyond. And if we cannot accommodate the amount of history that was requested within this limit, the system will notify you. Right? If it's a sporadic change, your once a month statistics aggregation in the data warehouse, and it happens once a month, so maybe you don't really care about it. If it's happening on a daily basis, either you need to go ahead and reset your SLAs in terms of how much time you want to be able to go, or you go and provision more space, right?
Is there any way of profiling that up front, rather than actually enabling replication?
Yes, so we provide sizing tools for both bandwidth and basically the history journaling. To make it very, very simple, we collect vCenter level statistics on the change rates for a good representation of the time that you think you want to protect. Take it into a spreadsheet, you'll get the result. Okay? Another thing that I want to mention here, again, since we're talking about mainly in the context of storage, is the efficiency, again, the aspects of efficiency versus cost, right? Performance and how much am I willing to invest. These journals are basically our space to allow us to go back in time, right? We want to roll the application 1 hour ago, we need to have some space to store the changes. The thing is that you may want your DR to be on a lower tier storage, or your policy will be that you want your DR copy to be on the same tier of storage that the production is, right? But you don't necessarily want the journal to be on your most expensive SSD disks, right? You can go ahead and set the journal to be on a lower tier storage. And you can basically say, my replica will go on my tier 1 storage, my journal will go on a tier 3 storage. That's good enough for me. Okay? And that can be done and set as part of the protection policy. There are things like one compression for people that cannot afford the bandwidth that they need for the changes, and it's a pretty impressive compression. And as we all know, DR is only worth what you are actually testing it, right? If you're not testing your DR, you don't really know that you have it working. And we allow you basically here to say, that's my test policy. I want to be able to test my DR every 1 month, 1 quarter, once a year. The system is tracking when the last test was done, and will let you know if you missed your test, if you did not meet your policy.
It triggers alerts.
And triggers alerts.
And all through vCenter. It's all integrated.
Okay. Next thing here, we were replicating into VCD, so we're selecting the org VDC of this customer. In this case, we came with a pre-configured environment where this customer have only one org VDC. We can, and how many of you know VCD well? Okay, so in VCD 1.5, one of the major feedback points that that repeated quite often were the fact that it's very hard to set different tiers of storage services in VCD. In 5.1, it was addressed to some extent. In 1.5, it was basically impossible to set different storage tiers.
Depends on what resource plus you're presenting to VCD.
Right, you had to set different providers and then but it was a hassle, right? It was inconvenient, right? You could do it, but you needed to go through all sorts of hoops in order to do it. What we basically allowed customers to do here is to assign different org VDCs to a single customer in our resource assignment or site management screen, and they could basically select, when they're replicating to VCD, the tier that they want to replicate and recover, replicate to and recover at, right? And it's basically a selection that they could have here. So I could have my platinum, gold, silver org VDCs, and I could replicate into them, recover in them, basically from the single screen. Depends on what was assigned to me. If VCD is not being used, and our own native resource abstraction capabilities are being used, the same concept applies with our own tools. So we allow you to select different storage, compute, and network clusters and resources, give them basically good representation towards the customer, and assign them as different targets for application. And of course, networks, right? What am I going to use, and am I going to use, which network am I going to use for recovery? There are a few other things here. There are things like and unfortunately, we lost the guy that asked, but you can designate a volume as a swap volume. Okay? If I have a volume that is marked as, that is holding the OS swap, there's no sense in replicating it, right? We can save on bandwidth and basically allow it to recover. We will see that it must exist when the VM recover, right? But you don't need to replicate it on a constant basis. And there are other things like pre-seeding, where you can basically do the seeding of band. We know that again, if you don't have enough bandwidth, you don't necessarily want to take your 100 terabytes of data and send them over the wire, right? And retire by the time it finishes. So you can basically ship them over and take them either from your backup or in any other way, ship them over and seed to them in an off-band seeding manner. So these are available. There's also network customization capabilities. Basically, we've done, if we go over everything that I explained, I've took the time to explain what it means to protect a new application, but it's generally a few clicks and you're done.
So I see that tick box up there for VCD guest customization
Right.
protection. Now you're just protecting the vApp catalogs?
In
Or are you
VCD?
yes, in VCD, or are you protecting deployed VCD apps as well?
So the VApps themselves,
Just apps?
the VApps themselves, yeah. So
Deployed VApps?
it's deployed and active, yeah. It's
And
not the
active.
catalogs.
So
it's
in
the
that,
actual
in
VApps.
that database that you're talking about, it's taking those change addresses, those unique identifiers in VCD and replicating them to the other site. So when they come up in their own organization, they can be linked correctly when the org comes back online?
So we basically make sure that the reason we have guest customization here is that, or the ability to disable guest customization,
Yeah.
is because that in many cases you don't really customize anything, right? You just want to take the VM with its IP settings and its identification and let it fail over in the remote side, right? So we can skip the whole customization altogether.
Sure.
If
sure.
you want to change IPs, you need to activate guest customization, and then VCD will assign it a new ID.
Right, so that's maintaining the catalog integrity, right?
Right, and not only that, even if you customize, we can return the ID back. So we know how to. Part of the thing is that when you recover the VM, and especially we can replicate VC level VMs to VCD as well, right? You don't have to protect. Here the source side does not have VCD, right? It's a standalone VM,
Right.
right? When you recover it in VCD, it will
Well,
it will
that's
get
that
the
was
ID.
my point is that, you know, when vCloud takes over a cluster and it becomes a resource cluster, every VM in there has a unique identifier
Right.
to it, and it's very hard to link that back up to the original organization.
So we are doing it in the background. If you disable guest customization, we don't need to return the VM name. The problem that you have here is that when the guest customization gets in, it's not only the identifier in vCenter that change, it also goes back to the host, to the actual VM itself. And then it creates recovery issues. So we know how to, we won't change the identifier that you see in vCenter,
Right.
but we know how to make the host present itself as it used to be before, so that you won't have issues with recovering it. Okay?
So it'll maintain, say for example, an org has 30 different VApps that were deployed in there. You can say that you're able to recover all 30 deployed VApps, regardless of how many VMs were in that VApp.
Right.
Okay.
Right.
Interesting.
And that's again the integration with vCenter with VCD is really deep.
That's the key component there.
That's in VCD. There are many things, you need to be able to identify the organizations. You have to know which organization VDCs are there. You have to be able to link to the org networks, right? You have to be able to identify the application, the VCD application that you want to, the VCD VApp that you want to protect and recover it as a VCD VApp in the remote side. You have to maintain all these capabilities, and
Well, that's
it's-
always the biggest problem with deployed applications in VCD is that
Right.
they're very unique to every resource cluster.
Right, so we have, I think that we've nailed it well. Okay.
Quick question, do you see a lot of demand for that? Because I don't, SRM isn't actually compatible with VCD, is it? I don't know if that's changed now. VCD.
The only
It's like
integration
one.
with that is on the management side. That's the only. There is some white papers that were deployed
Right.
to combat rebuilding your VCD environment
Right.
and rebuilding your catalog. But as far as protecting all the VApps that are running inside of VCD, this is the first time I've seen a product that could do something like that. Is to redeploy all those VApps, running VApps in every org.
Right. And to the point, what you have is the difference between protecting an application and recovering in an org VDC,
Mhm.
right, versus protecting VCD itself.
Do you have a white paper on that?
Yeah,
As
we
far as-
have
Okay.
quite a few of them,
Okay.
so definitely. So just to kind of recap on this point, and maybe just to kind of give you a sense on what it means, right? Most of the SLA parameters have defaults. If you don't need to change them, you don't touch them. You select the org VDC, potentially the two networks, and if you didn't need to change anything, you click save and you're done.
And that's going to do this piece. We've gathered up the VMs to be replicated. So in order to split this in, could you go to the summary and let's look at the RPOs of the VPGs and also the VCs to VCD view, and then we'll cut it and go into advanced.
Right.
So what we're going to show you is just the VPG list. So we've done this a bunch of times. We've got the VPGs created, and once we get to their VPG list of the whole site, then it'll show the relationships between vCenter to vCenter, but also if Site 3 were a VCD, a vCloud Directory instance, then you'll see that as well, if we can get some cooperation there from them. So we could say that's a, your, sorry, your own hosted environment, and this will segue into the advance of a hosting provider, which is a very popular thing with us and service providers, because they can use vCloud Directory integration. Try to hit it again here.
So what kind of companies are buying this product right now? Is it mostly service providers and bigger shops, or is it all over the place?
It's a good mix. It's an extremely good mix.
It's all over the place,
Yeah,
literally and figuratively. It's all over the world.
Yeah.
And it's also service providers. When we announced cloud integration in, what was it, June, July, we had like over 30 service providers, because they saw this independence from needing to match up storage array replication to customers.
Which any hardware.
Yeah, to really any hardware. That's very popular. And then we see a lot of our basic packages, 15 VMs in enterprises, and we see that a lot too, because of the same reason. Just maybe different storage, different hardware altogether, but they still have the requirements of protecting those VMs. Right. So if you would, Hen, show the type. These happen to be, all three of them are going to vCloud Director, so that's why you see the symbols a little bit different on the type. That's.
Yeah, I can go to the.
Yeah, go to the
vCenter level.
Yeah, and then we'll look at the RPOs as well, and then
right.
we'll stop this section.
Yeah. Any questions on what you saw so far? Okay. So maybe one thing I do want to be able to show before we go and discuss all sorts of other capabilities is basically to recover a VM into VCD. I think that will be interesting to see. So first of all, you can see here, this is a different type of endpoint, and it's replicating VC into VC. So although it is replicating into the same cloud vendor, actually here the resources that were assigned are VC level resources. They are not VCD level resources, right? It's not replicating into an old VDC. And you can see the different KPIs that we have here and the actual RPOs.
Those are 6 seconds each. They don't always match. Sometimes they're up and down.
Yeah.
All right, so that's got us to the point where we've got the architecture. We discussed creating the VPGs. We're showing the relationship between 1 to 2 to multiple sites.